We're going to solve systems of linear equations using Gaussian elimination. That word is Gaussian. Okay, we're going to solve systems of linear equations using Gaussian elimination. And you have to have some patience when you're doing this. You cannot get in a hurry. We're going to do 2 examples, and you're going to have 3 to work on for homework. Okay, it's kind of like, I think it's kind of like a puzzle. If you like puzzles, you'll probably like this. If you don't like puzzles, then you won't like it. So. All right, so we're going to start off with a simple one. 5x plus 3y equals negative 31. 4x plus 2y equals negative 22. This is an example of a system of linear equations. We want to solve this. All right, there are other ways to solve this besides Gaussian elimination. And you mainly know 2 different ways to solve this. What are the 2 ways we can solve this type? That you've learned in Algebra 1 and Algebra 2. Substitution is one way. What's the other way? What did you say? Elimination is the other way. Okay? Gaussian is closer to elimination. Alright, so there's a little bit of background material we need to give you. What we're going to do is we're going to take this and we're going to turn it into a matrix, and then we're going to, what's the word I'm looking for? We're going to make some adjustments to it. Okay, and there are 3 different things we can do to our rows when we're trying to do Gaussian elimination. First thing is interchange 2 rows. What do I mean by interchange 2 rows? Somebody said something. Switch. Okay, so if I have row 1 and row 2, if I'm interchanging rows, then I'm going to take row 2 and make it row 1, and take row 1 and make it row 2. So I can switch 2 rows. Second thing is I can multiply a row by a non-zero constant. So what are some examples of a non-zero constant? 2, negative 3, 1/2, 1/4, negative 1/5, and so on. So I can multiply a row by anything. Okay, and the third one is the one we're going to use a lot today. And that is we're going to multiply a row and then add it to another row to get the desired result we're looking for. So these are the 3 we're looking at. This one, we don't use this one very often. This one we're going to use the most, and we'll also use that one as well. But 3 is the one we're going to use the most. All right, everybody have those written down. All right, so the first thing we're going to do is we're going to write this in matrix form, which means we're just going to take the coefficients. So I'm going to have 5, 3, negative 31, 4, 2, negative 22. So I'm going to just write the coefficients and use those coefficients to write a matrix. And here's what we're going to try to do. We want to try to, you don't have to write this down, we want to try to get it into row echelon form. Okay? And these are some of the properties of row echelon form. You do not need to know it. Once we talk about it, you'll understand what it is. First rule is, if I have a row that has just zeros, it's got to be the very bottom row. Okay? So if you notice on these examples down here below, over here, I've got a row of just zeros and a row of just zeros. Notice that they're both the bottom row. So that's the first rule. If you have a row that's all zeros, it's got to be on the bottom. All right. Then for each row that does not consist of entirely zeros, the first number has to be a 1. So if you've got a row that doesn't have all zeros in it, the first number has to be a 1. So notice every one here, the first number on the left, all of them are a 1. Okay, so that's the second rule. And the third one, if I have two rows that aren't totally zero, the leading one in the higher row must be farther to the left than the leading one in the row below. So right here I've got two rows. They both have numbers in them besides 0. What this is saying is, notice that the top row of the 1 is on the left of the one that's below it. Okay, so what we're trying to get is, we're trying to get a diagonal of just 1s. That is our goal. Okay, so we're going to use those three, what did I name those? What were those called? No.
Like elementary
operations. So we're going to use those three operations to turn our matrix into something that looks like these. Okay? Once we get it to that point, then we're going to be able to get the answers we're looking for. Now, like I said, you have to show some patience. Because it's going to take, this first one, we're starting out with a smaller one, just to give you the general idea. And then the second one is going to be a bigger system of equations, and you're going to have to show some patience on that. So, what is the first thing I need to try to do with this matrix if I want to put it in row echelon form? What needs to happen? I need to eventually get zeros, but what else? And where do I want my first one to be, Jasmine?
I don't know where the 3 is.
Not where the 3 is,
The 5?
where the 5 is. So the first thing I want to do, the very first thing I want to do is turn that into a 1. So we want to use those 3 operations we're allowed to use to turn that into a 1. So any thoughts on how I can turn that into a 1? And let's revisit those real quick. So I can interchange 2 rows, which means I can switch rows, but that's not going to help me because both of them don't start with a 1. Neither one of them starts with a 1, so that's no good. I can multiply it by 1/5, but we're going to see that's not what we want to do. What we want to do is multiply the other row and then add it to that row to get the 1. Now let's see why we don't want to multiply. Why do I not want to multiply by 1/5? I'm going to get fractions. I don't want fractions until the very end. So that means I want to multiply the bottom row by something and then add it to the top in order to get that 1. Negative 1. So here's what you do. I'm going to do -1, row 2 plus row 1. I want you to write it out to the left. When you do these operations, only one row can change. You can only change one row at a time. So since I'm changing row 1, that means row 2 has to stay the same. So row 2 has to stay the same. So I'm going to do -1 times row 2 and then add it to row 1. So -1 times 4 is -4. -4 plus 5 gives me the one I'm looking for. -1 times 2 is -2. -2 plus 3, there's another 1. -1 times -22 is 22. 22 and -31 gives me -9. So I've got my first goal. I was trying to get the top left to be a 1. Questions on what we've done so far?
So the bottom one doesn't change at all?
Only one row can change. And the only row that's going to change is wherever you have this written. And whatever row is in that spot, that's the row that changes. So I have row 1 in that spot, so row 1's the only one that can change. Any other questions? All right, now what do you think we want to do?
Yeah. Do we want to put a 1 when the 2 is?
We eventually want to get a 1 there, but that's not what we want to do next. Ethan?
You want to get the 4 turned into a 0?
I want to turn the 4 into a 0. You always want to take care of column 1 first. You want to get column 1 to look like it's supposed to be. And I want it to be a 1, and then everything else underneath it needs to be a 0. So I take care of column 1 first. And you work from top to bottom. So, how can I make this a 0?
Multiplying the top row by -4.
Multiply the top row by -4 and then add it to it. So I'm going to do -4, row 1 plus row 2. So the only row that's going to change is the second row. I know that for 2 reasons. I wrote it to the left of row 2, and row 2 is the second row listed. So that means the top row is going to stay the same, but the bottom is going to be new. So -4 times 1 is -4 plus 4 gives me the 0 I'm looking for. -4 times 1 is -4. -4 plus 2 gives me -2. -4 times -9 is 36. 36 and -22 is 14. So, I have column 1 the way I want it. I have a 1 at the top, and everything else underneath it is a 0. So that means I'm ready to move over to column 2. What do I want to key on in column 2? I want to put a 1 where? Where the -2 is. Okay, do I care about what that number is? No, all I care about is that this one turns into a 1. So thoughts on how I can turn that into a 1?
Switch the rows. No, that makes sense.
It's real easy.
Interchange the 2 rows?
I don't interchange because if I interchange, then I've got a 0 here and a 1 here. I need that 1 there. You guys are thinking too hard. -1/2 times row 2. So I have 1, 1, -9. I have 0, 1, and -7. And I have reached my goal, which is to turn this into row echelon form. How do I know it's in row echelon form? There's a 1 at the top left, and there's 1's diagonal. That tells me I'm in row echelon form.
Does it matter how many steps you go through? You said that you can only change 1 row at a time.
Right. Some of them are going to take more than others. Alright, so here's what we do. Once I get it in row echelon form, I'm going to write it back in the original form. Okay? So I have x, y, and -9. So I'm going to have x plus y equals -9. And that's what I get out of that top row. What do I get out of the bottom row? Y equals -7. So I get y equals -7. What can I do to figure out what x needs to be? Plug in y. So I have x plus -7 equals -9. So that means x equals -2. And I have solved this system of equations. What can I do to make sure my answers are correct? Plug it back into the original. So 5 times -2, -10, -7 times 3. Does that give me -31? Yes, so that tells me I did it correctly. Okay, so that's our goal. Now we're going to move to a bigger system. But it's the same process, you just got to be patient.
Can I do a y equals -7?
Well, I wish you'd ask me.
I have it on my paper.
What? I'm just kidding.
Let me write this down so everybody can start writing it down, then I'll come talk to you.
0, 1,
I don't know what you said. These strings have zeros left. It's okay, just pass them out after that.
Should take care of it.
UAT.
Notice 5 and 4, they belong to the x's. Do you agree? The 5 and the 4 both came from the x. So that means this column right here always represents the x's. Okay? The 3 and the 2 came from the y's. So that means this column right here is always the y's. So this bottom row, I've got 0x I've got 1y, and then it equals -7. So the 0x doesn't mean anything, so all I have is y equals -7. So that's where the y equals -7. Alright, -3x plus y plus 6z equals 15. 2x plus 2y minus 5z equals 9. 4x minus 5y plus 2z equals -3. So what's the first thing I want to do?
Take the coefficients. Take the coefficients.
Alright, coefficients, make your matrix. So -3, 2, 4, 1, 2, -5, 6, -5, 2, 15, 9, -3. Now, one thing that's very important is to make sure you have it written down correctly to start with. Because if you don't have it written down correctly to start with, then you're in trouble. You're going to do a lot of work for nothing. So make sure you wrote it down right. -3, 2, 4, 1, 2, -5, 6, -5, 2, 15, 9, -3. So I've gotten it down correctly. All right. So what is my first goal?
Get the one.
I need to make this a 1. Ideas on how I could make that a 1.
2R2 plus
I could multiply the second row by 2 and add it to the first one. Does anybody see another option? That will get it done.
Multiply the bottom row by 1, and then add it to
Well, if I multiply by 1, I don't really need to multiply.
the, oh wait, can you do that? Can you
Just
do
add it. So the easiest thing is to take row 3 plus row 1. But what Taylor said will also get it done. But this is a little bit easier because I don't have to multiply. So the only row that's going to change is which one? Row 1. Everything else is going to stay the same. So 4 plus -3 is 1. -5 plus 1, -4. 2 plus 6 is 8. -3 plus 15, 12. Everything else must stay the same. So I've reached my first goal. What's my next goal? Not a 1. Which 2 are you talking about?
Zero, don't you?
There's two. The first two are zeros.
I want this to be a 0. Remember, what did I say you want to take care of first?
The first row.
The first column. So I need to make sure the first column is the way it looks before I move on to the second column. So how can I make that 2 a 0? Very good. So multiply the first row by -2 and then add it to the second row. Now here's a hint for you, and hopefully some of you are going to catch on to this. Once I make the top one a 1, I'm going to use that row to make everything beneath it a 0. So once you get the first one to be a 1, then you use it to make everything below it a 0. So that means the top row has to stay the same. Alright, so -2 and then plus row 2. So that's going to be a 0. That's going to be 8 plus 2, which makes that a 10. That's going to be -16 and -5, which is -21. That's going to be -24 and 9, -15. The bottom row has to stay the same. So we have reached our second goal, which was making that 2 a 0. What's my next goal?
Make the 4 a 0.
Make the 4 a 0. How am I going to make that 4 a 0? Perfect. So -4 times row 1 plus row 3. Notice which row did we use to make both of those 0?
row
We use row 1, just like I said we would. Make row 1 a 1 and then use it to make everything below it a 0. So that means I've got a 1, a -4, an 8, and a 12. 0, 10, -21, -15. And then my last row is going to be a 0. That's going to be 16 and -5, which is 11. -32 and 2, -30. And -48 and -3, negative 51. So I am done with the first column. The top of it is a 1, everything beneath it is a 0. So I'm ready to move over to the second column. What should I focus in on the second column? Make the 10 a 1. That is correct.
Do you not want to start with the 0 in row 3 though?
You do one column,
Yeah.
and then you want to start at the top and move down. So I need to make that 10 a 1.
Could you just multiply row 3 by -1?
Multiply row 3 by -1 and
Add it.
add it. I can do that. So -1 row 3 plus row 2. So that means the top one's going to stay the same. 1, -4, 8, and 12. My middle one is going to be a 0. That's going to be a -1. That's going to be a 9. And 36.
Wait, it can be a negative?
Well, we're going to deal with that in just a second. But yes, I'm glad you brought that up. Okay, and as Taylor said, it's a -1 right now, but I want it to be a positive 1. So all I have to do is what? Multiply that row by a negative. So I'm going to make this, just change those two, and now I've got it where I want it. All right, what's the next thing I want to do? Make the 11 a 0. Good. How do I make that 11 a 0?
Row by 11.
Yeah. Remember, the row that you have, the row that you make a 1, that's the one you're going to use to make everything below it a 0. So I just made row 2 a 1. I'm going to use that to make what's below it a 0. So I need to do -11 row 2 plus row 3. Oops. I wrote that on the wrong one, didn't I? Alright, so that means this one is going to stay the same, this one is going to stay the same, and the last row has to change. So I'm going to get a 0, I get a 0, so -11 times 9, or -9 is 99, subtract 30, 69, and then -11 times -36. I needed a calculator on that, which was 396, and then add that to -51. I get that. So I got one more thing to do.
Change 69 to 1.
Change 69 to 1. And what do I do to get that?
Times row 2 by.
Here's a hit. Once I get down to the last thing I'm working on, all I gotta do is divide. So just do row 3 divided by 69. That's the one you want to divide on, is the last one. You can divide when two things happen. I can divide early as long as what happens?
No
Everything is divisible by it. Okay, so if everything's divisible by it, go ahead and divide. If it's not divisible, don't divide. But on this last one, I can always divide, even if it gives me a fraction. So I have 1, -4, 8, 12, 0, 1, -9, -36, 0, 0, 1, and 5. And I have achieved row echelon form. I've got a 1 starting in the top left, and I've got diagonal 1s, and then everything to the left is a 0. So now we're ready to find our answers. So, what does the 1 and the 5 at the bottom tell me? That tells me that z equals 5. Is everybody on board with why that tells us z equals 5? Everybody okay with that? Reagan, you good? Both? Kinsey? Ray? Fine? Matt? We're good? Okay. So what does row 2 tell me? Right, but I want to write down row 2 first before we plug in. Y minus 9z equals negative 36. Everybody okay with that? Getting that from row 2? Jasmine? Taylor? You good? Okay. So now what do I want to do? Plug in 5. So y minus 45 equals negative 36. Y equals 9. So I've got z and y. So Preston, what do I get out of the top row?
X minus 4y plus 8z equals 12.
Very good. So then we plug in 9 there. We plug in 5 there, and that'll tell me what x needs to be. So x minus 36 plus 40 equals 12. I get x equals 8. Real quickly, I can check by plugging in. Does it matter which one of these I plug into? No, they should all work. Okay? I'm going to choose the middle one just to make it different. So I'm going to plug 8 in. 8 times 2, 16. Then I'm going to plug 9 in. 9 times 2, 18. I'm going to plug 5 in. So 16 and 18, that gives me 34 minus 25, which gives me 9, which matches that. So that tells me we have done it correctly. So again, start with the top left. Get it 1. Then we use that row to make everything underneath it a 0. We move to the next column. Get a 1. Use that to make what's underneath it a 0. Move over, make that a 1. Then we can get to our answer. Questions?